Hello, today we are going to solve the problem of the day from LeetCode. In this problem, we receive two strings, and we need to answer if the second string contains a permutation of the first string. This problem is, the idea behind the problem is very simple, because what means to have like one string is a permutation of another string? We can reduce that to basically having the same amount of the same elements and also the same amount of each of them, because then the order doesn't matter because it's a permutation. The order of the elements can be any, but we need to follow the condition that the elements are the same and also they are present in the same frequency. For instance, if we have ABC and CBA, we have 1A in both strings, 1B in both strings, and 1C in both strings. Then that we know that this is the idea that we need to check, we can think, okay, in string 2, I can create like in a prefix way, a frequency map for each of the characters. For instance, I can say, okay, until the position E equals 0, I have like 1A and then 0B and then 0C and then until the last letter of the alphabet. And then the same for E equal 1. And in this way, like in a prefixed way, we can, like, let's say, convert the string to a map which stores the frequency of each element from 0 to E. For instance, in this example, it will be in this way, and then for E equals 2, then we will have 1C. And then for the remaining 1 zeros. Then we can only like check what is the other requisite that we have, that the length of two, let's say, strings that are a permutation of the other one is the same. That means that, okay, let's assume that the length of our permutation that we want to check is 2. Then we will need to compare the elements between the initial status of the frequency map and the position that is after the length. For instance, in this case, it could be this for a length of 2, and then it could be this for a length of 3. In that way, we can only subtract our frequency vectors or maps, and then we know how many elements are between, like, in that substring built from the indexes that I have mentioned, and then we can compare with the frequency map of the string S1, let's say, and if it matches, then we will have a permutation. If it doesn't, then we don't have a permutation. Okay, I hope that the explanation was clear. I think that it will be clear in the coding part. Okay, let's start storing the length of the strings, because we will need this. We can already generate our frequency map. Or also, another thing that I didn't mention is that to generate the frequency map, I am not going to use maps, because at the end, these are characters, and this can be represented as a vector of 27 elements. And then, yeah, in that way I can save the complexity of having a map, because then the insertions in the vector will be in constant time. Or the replacements, let's say, because we are already going to initialize the vectors with the length of 27. Okay, then let's call hash or frequency, because we already use the frequency of S1, sorry, because that is the substring that we need to find. Also, we're going to store the length of the alphabet with a constant called LA, with a variable LA. And then this needs to be initialized with 0 because we don't have initially any character. Then we're going to iterate S1, and the frequency of S1. Okay, this is basically the index that goes from 0 to 26 for 0 for A and 26 for C. And then this should be increased each time that we find an element. Then this is frequency map for S2. Now we need the frequency maps for S2 in a prefixed way. We need to literalize now a vector of vectors because each frequency map is a vector, and we are going to build one from 0 to E, and E will basically go from 0 to the length of the string S2. And then also this, because usually for when we build prefixed properties, we will need like the initial status that has 0 for all of the elements, and for that reason we're going to increase 1 to the length of S2. Then initially, like, the next prefix frequency map will be the same as the current, but we only need to increase it for the current appeared character, let's say, because for each character that we traverse, we are going only to find one character because that's obvious, and we need to increase the count for this found character. Okay, we already have the frequency maps vector for S2 in a prefixed way. Now we can start our finding of the, if we can start checking if we can satisfy the conditions. Let's remember that we are going to check like for substrings of length equal to the length of the string 1. For that reason, we don't need to go farther than this position, because otherwise we won't have the enough elements to have a substring of this length. Then we can use also here a answer. Let's say we'll initialize the answer as false, and then if we find a substring, then we will update that as true, and then break the iteration of the loop. Now we need to compare the or calculate the amount of elements, or let's say the frequency map for the substring that goes between index E and E plus L's length the string 1 less 1. And to calculate this, we only need to subtract our prefixes that we have already calculated here. let's say we will initialize also another flag that will say true, and if we find a no coincidence, let's say that we find that this substring is not valid, then we will update this as false. And yeah, but if the current is valid, then we can stop our search because we already find a valid substring. Then we are going to iterate over the characters of S1, and if the amount of characters of S1 is different from the amount of characters of our calculated substring, then we will say that the current valid is false, and we also can stop the iteration here. And how we calculate the frequency for the substring of S2, basically our word or with our prefixes is vector that we have already calculated for S2. Okay, let's see. Okay, we have true and false for the first two examples. That is correct. Let's submit this. Okay, let's submit this. Okay, I hope that the explanation was clear enough. If not, let me know in the comments. Thank you.